Assalamu alaikum students. Today we will start first chapter of second year chemistry, which is chapter 17, and its name is group 2 elements. Group 2 elements are also called alkaline earth metals. In this chapter we will study the properties and trend of group 2 elements that will include electronic configuration, reactivity and common compounds of these elements. Reactivity in term of electronic configuration, reactivity series and oxides of these elements, thermal decomposition and analysis of group 2 compounds, especially involving carbonates and nitrates. And we will also study thermal stability of nitrates and carbonates, solubility of group 2 sulfates and hydroxides, qualitatively variation in solubility and enthalpy change of solution, complex ions and its formation, complex ion and its application in the formation of group 2 compounds, extraction and purification process of group 2 elements, and industrial and everyday uses of group 2 compounds. Let's start. First, introduction of group 2 elements. Group 2 elements are S block elements, and we know that S block element mean that last electron of elements enter into the S subshell. They are also called alkaline earth metals due to their metallic nature and occurrence in earth crust. These elements have moderate reactivity, that is, their reactivity is in between the highly reactive alkali metals. Alkali metals are more reactive than alkaline earth metals, and transition elements are less reactive than the group 2 elements. Calcium and magnesium are amongst the eighth widely occurring element on the earth crust. Beryllium, that is the first member of this family, that is used to make copper alloy harder for aerospace material, while magnesium is important part of chlorophyll that represent the green matter in plants. Magnesium, calcium, strontium, barium, these are essential components of fireworks. Due to their vibrant flame color, these elements show color when they are burned. Let's see properties and trend of group 2 elements. All these elements have 2 electrons in their outermost S subshell, that is S subshell is complete in this case, in this family. They exhibit same chemical properties but they vary in physical properties. Properties vary from top to bottom. Few characteristics are represented in this table. So let's see properties which are shown here for these members. This family starts from beryllium, magnesium, calcium, strontium and barium is present at the bottom. So atomic number increase from top to bottom. Beryllium has 4 atomic number and so on. Atomic number increase as we move downward. Electronic configuration is shown here. Helium has 2 atomic number, so this configuration will be 1s2. So instead of writing 1s2 we can just write helium. And for magnesium, atomic number is 12 and its electronic configuration is here. Neon mean we have electronic configuration which is representing 10 electrons, 1s2, 2s2 and 2p6. So instead of writing all of these details we will just write neon, that will represent this electronic configuration, and valence shell is 3s2. Calcium has 20 atomic number and its configuration is given in short form configuration of argon and 4s2. For strontium we have krypton configuration and 5s2 is the valence shell. And for barium atomic number is 56, we have configuration of xenon and valence shell is subshell is 6s2. Metallic radius increases from top to bottom as we can see here. 112 is the Picometer is the atomic radius of barium, and after that atomic radius is increasing and maximum is for barium, which is present at the bottom. Ionic radius, ionic radius also increases as we move from top to bottom. Beryllium has lowest ionic radius, which is 31, and after that maximum is the barium, which is 135. So this radius is representing the bivalent cation. First ionization energy is maximum for beryllium, and ionization energy is decreasing from top to bottom, and barium has lowest ionization energy, and reason for this is that atomic size radius of the atom is increasing as we are moving downward. So it will be easy to remove the electron from the barium as compared to the beryllium. So less energy will be required for barium and highest energy will be required for beryllium. Second ionization energy, in case of second ionization energy, again it is highest for the beryllium. So second ionization energy is the energy which is required to remove the second electron from the valence shell, and it is highest and it is lowest in case of barium. Electronegativity, that is also decreasing as we are moving downward, so it is lowest for the barium. Melting point is highest for beryllium and it is lowest for barium. Again, density is highest for barium, it is increasing from top to bottom.